Today we're going to do Unit 5, Lesson 7, looking at exponential graphs and equations. So the first thing you need to do is be able to remember how to write powers of 2 or any powers. So anytime you have exponents that have the same base, you're going to add them. So 2 to the 4th times 2 to the power of 0. 4 plus 0 is 4, so you have 2 to the power of 4. You do the same thing if that exponent is negative. So 4 plus negative 1 gives you 3. So it's 2 to the power of 3. 4 plus negative 3 gives you 1. So it's 2 to the power of 1. And then 4 plus negative 4 is 0. You have to write 2 to the power of 0 because 2 to the power of 0 is 1. If you just wrote 2, that would be incorrect because 1 is never 2. All right, so let's look at a problem. We have a marine biologist that estimates the structure of volume of coral, and it's 1,200 cubic centimeters, and they notice that it doubles every year. So we need to write an equation in the form of y equals a times b to the power of t to represent this relationship. Remember that a is always your initial value, and b is your growth factor. So in this problem, our initial value is 1,200 cubic centimeters, and it's doubling every year, so 2 is our growth factor. So we're going to have y equals 1,200 times 2 to the power of t. Then if we want to know what the volume of coral is when t is 5, 1, 0, negative 1, and negative 2, we can just plug in those values for t and solve the equation. So 1,200 times 2 to the power of 5 gives you 38,400. To the power of 1 is 2,400. To the power of 0 is 1,200. And then if we plug in a negative exponent, that doesn't make our answer negative. It just means that we're going to half that. So instead of negative 1 raised to the power, you can write that as 1 half to the power of 1. So we're cutting that in half because you're going backward. The negative values don't mean that we're looking at a negative time. It means that we're looking at a time before. So when t is negative 2, that tells us that we're looking at 2 years before the initial measurement of 1,200. So in a certain year, the volume of coral is 37.5 cubic centimeters. Which year is that? Well, we can continue the trend and continue cutting it in half. And so we would end up with 5 years, or t is negative 5. So we're looking at 5 years before the initial measurement. All right, so let's look at these on a graph. So we have 3 graphs here. And it's important to notice that your x and y axis are different for each of these. And if the window isn't set correctly, we can't see the data. So for the first graph, if you look at your x and y axis, it goes from negative 2 to 4 on the x-axis, and your y-axis only goes up to 2,000. So this window is too small because it only allows us to see 2 data points, and we can't tell any trends or see anything that's happening with the data. For graph B, the window is going from 0 to 1,000,000 on the y-axis, and that is much too large. We can see multiple data points and you can see the trend, but it's hard to estimate what's happening between like negative 1 and 5. They're all so close to 0, you can't tell what's going on, and you can't make a good estimate from that. If you look at graph C, we have the points a little more spread out, and it's only going from 0 to 600,000. So that you can still see the pattern like you do in B, but you're able to make a better estimate of what those values are on the x-axis between 0 and 5. All right, let's look at another example. We've got a person that took some medicine, but they don't remember how much they took, and so they're going to take a blood test every hour to track how much is in their system. So it's important to know that time is measured in hours since the blood test was taken initially, and we need to figure out what our growth factor is and what our initial value is. Based on the table that you're given, we know that 0 is at 100, so that's our initial value. And we know that it's decreasing by half every time because 50, to get from 50 to 100, you cut it in half. And then 50 to 25, you're also cutting that in half. And so if we want to know what the amount of medicine in the body was an hour before at -1 and 3 hours before, we would go backwards from that. So we would double it. So -1, we would double 100 and get 200. And then double that again gives us 400. So that would be -2. So you have to double it once more to get 800. So these values, when t equals 0, is the initial time that the doctor took the first blood test, and that was 100 milligrams. And t equals -3, it's talking about 3 hours before the initial test. All right, so if we know that the medicine was taken 5 hours before, and they didn't have any other medication in their body, we would plug in -5 for the equation, and we would get 3,200 milligrams. Okay. Based on the graph, when do you think the patient will have 500 milligrams remaining in the body? So you can look at the graph here. And on the graph, if you look where 500 would be on the y-axis, you would go over, and toolbar's in the way, but it is between 2 and 3 hours before the first blood test was taken. And then when would we have no medicine remaining in the body? Well, mathematically, we would never get to 0 because anytime you continuously cut something in half, you're always going to have half of it remaining. And so you'll never get to 0, but it will eventually get so small that you can't see it or detect it in the body. And so that would happen sometime after 10 hours because 1/10 of a milligram is about all you can detect in the bloodstream. Right, so hopefully now you understand that negative exponents do not mean that your values are negative. It just means that we're talking about sometime before the initial amount. So -2 is 2 hours before the initial amount. -5 would be 5 hours or 5 days or 5 years or whatever amount of time the increments are in.